Well, we're now going to talk about inverse trigonometric functions. And we're going to start here with the inverse sine functions. But before we get too much into that, let's do a quick review on inverse functions themselves and some things that we have already learned. Well, we know that every relation has an inverse, but every relation that is a function, its inverse may or may not be a function itself, and we can determine that by the horizontal line test. And with the horizontal line test, if a horizontal line crosses the graph of the original function more than one time for any value of y in the range, then its inverse is not a function. And if you think about just the basic sine function, which let's see, oscillates, well, I'm going to draw it up here, oscillates like that with a period of 2 pi. The sine function itself would not be a function unless we restricted the domain. Now, another thing we know about functions is, and the inverses is that the values of the domain and the values of the range swap. In other words, the values of x become y, the values of y become x. That's what happens with an inverse. So in other words, if we saw an inverse relation, let's say an ordered pair, 2, 4, well, its inverse would be 4, 2. The x's and the y's just swapped places in that ordered pair. And so these would be inverses of each other. So when we're talking about a sine function, which has a range going from -1 to 1, if that becomes the domain, in order for that to be a function, we're going to have to restrict. If we restrict the domain of the sine function from -pi/2 to pi/2, then that, by restricting the domain of that sine function, its inverse becomes a function. And in fact, over here on the right, this is the graph of a sine inverse sine function, where we've got a domain out here at -1 to 1. That would be our domain, -1 to 1, and our range is -pi/2 to +pi/2. That's our domain. So our domain becomes our range becomes our domain. And that's how I set this up with my window settings. I set my x minimum at -1, my x max at 1. I have a scale of 1/2 just to have it out there. And then I set the range at -pi/2 for the minimum, pi/2 for the maximum. And I think I put a range in there at pi/4 just to see, so we could see a little tick mark. Now, so that means when we're evaluating the sine functions, we're talking about the right half of the unit circle, just the right half, where our range is going from -pi/2 to pi/2, and our values of our sine are going to be restricted between -1 and 1. Let's see, there's something else I wanted to talk about on the, oh, well, I guess here on the unit circle, and I didn't include the unit circle because by now we need to be memorizing what's happening with that unit circle between as far as cosine and sine values. Let's start here with pi/4. Well, at pi/4, we'll put it down here. It's actually pretty easy in that first quadrant. The cosine is square root of 2/2, and the sine is the square root of 2/2. Now, what about at pi/6? pi over 6, which kind of corresponds to a 30-degree angle if we were measuring it not in radians but in degrees. And at pi over 6, then our cosine is square root of 3 over 2, and the sine is 1/2. And at pi over 3, let's say right about there, sloppy drawings, but I hope you get the point. At pi over 3, our cosine becomes 1/2. Let me put parentheses around all these things. And our sine becomes the square root of 3 over 2. Now, since we're dealing with just the right-hand half of the unit circle for these general angles, in the first quadrant, the cosine and the sine values are all positive, but in the fourth quadrant down here, our cosine is positive, but our sine are negative. Okay, hopefully that gives a little basis. You want to review this information there in your book and get really familiar with it as far as the restriction on the domain and how we can do that. Oh, I remember now the other thing. We also used inverse functions quite a bit when we were just trying to find the angle measures of any angle if we know the sine and the cosine. So we're accustomed to using that, but now we're just talking about the inverse functions of that. And again, we're having to restrict the domain. So let's evaluate a couple of these. All right, so the first, and this is something else. You'll often see the inverse sine noted as either arc sine or maybe what we're used to here, the inverse sine. These are the same thing. These are just different expressions for the same thing. So the arc sine is the same as sine tan -1 or the inverse sine, and vice versa. So here we go. So what is the arc sine or the inverse sine of square root of 3 over 2? Well, where did we say that the sine was the square root of 3 over 2? And this is positive, by the way. Well, that would be at pi over 3. At pi over 3, angle measure, pi over 3, or the radian, the pi over 3, well, when that's our reference angle, the sine is square root of 3 over 2 in the first quadrant. Now, what about the inverse sine of negative pi over negative 2 pi? Well, now remember, we're only dealing with this right half of this unit circle. And for it to be negative pi over 2, we'd have to come all the way around over here in a clockwise direction. And so that's outside of our restricted domain of the sine function. And so this does not exist. Now, how about the arc sine or the inverse sine of -1? Well, where's the sine equal -1 on the unit circle? Well, it's right down here. Cosine is 0, sine is -1, and so this, the inverse sine or the arc sine of -1 is negative pi over 2. I hope that wasn't too confusing.